This segment introduces our unit on exploring and understanding addition. As an elementary teacher, addition will likely be the first arithmetic operation you will teach to students, so a complete understanding of the process, its properties, and alternate algorithms is imperative. How many words or phrases, aside from add, can you think of to describe addition? Combine, total, put together, count up, tally. Just as there are numerous ways to describe addition, there are numerous ways to model it. When we visualize addition, we usually think in terms of objects. If we have 2 toy trucks and add 3 more, how many toy trucks do we have? This type of pictorial modeling represents a discrete amount. Discrete amounts are those which can be counted separately or independently. We can physically count each individual truck. Here's another type of pictorial model using discrete numbers. If we have 3 video game controllers, and buy 1 more, we now have 4 video controllers. Again, discrete pictorial models show amounts which can be individually counted. Some numbers represent amounts that are not discrete, such as measurements. These are referred to as continuous amounts, or numbers. How can we model addition problems for these? We can still use pictures to represent the numbers. For example, if my glass has 4 ounces of milk, and I add 4 more ounces, I now have 8 ounces of milk, enough for another cookie. Even though I am using numbers which are not discrete amounts, I can still represent the addition problem using pictures. Another way to model addition is by using a bar diagram. Both discrete and continuous amounts can be represented this way, as the amounts and their relationship to the whole is the aspect being emphasized. Let's go back to our previous examples for comparison purposes. In our first example, we added 2 trucks plus 3 trucks to acquire an answer of 5 trucks. In a bar diagram, we would show that a bar of 2 plus a bar of 3 creates a bar of 5. Here we can see the relationship 2 and 3 have to 5, illustrated as the concept of parts to whole. Rather resembles fractions, doesn't it? Our milk problem can be modeled similarly. If we have 4 ounces and add 4 more, we end up with 8 ounces. Bar diagrams also provide a foundation for understanding fact families, or the relationships between numbers in inverse operations. An additional method for modeling addition is to use a number line. A number line consists of a horizontal mark divided into equal sections, with 0 usually marked at the left end. In order to model an addition problem, we first find the number with which our problem begins on the line. Our earlier truck problem would start at 2 on the line. As we add more trucks, we move further to the right until we have added the amount of 3. The location where we end up is the answer to our problem, in this case, 5. For the milk example, we start at 4. And add 4 more, and see that our result is 8. To review, We have looked at 3 popular ways to model addition problems using pictures, bar diagrams, and number lines. What additional methods can you create?